Howdy, welcome to room 105. This is going to be a video about getting the spacing correct to cut slots on a brand new nut, or to check if the nut you have has good spacing or not. Now you can eyeball this. My very first guitar I made, assembled, I eyeballed it. It was adequate, but it was not good. I really didn't know what I was doing. There's some pretty reliable ways to get this figured out now. Number one thing, you can give yourself about 1/8 of an inch. I know there's only 4 strings. This is just for example. I'm not doing a bass neck, but you could leave yourself 1/8 of an inch and 1/8 of an inch. Divide everything else 3 jumps, or in a guitar 5 jumps, and space those strings equally. That'll work. I think there's a lot of cheaper instruments that are done that way. I think a lot of home luthiers do things that way just to get it done and do it. But what I read about was better, and I like this. I tried it and I like it. It's a subtle difference. But to do it nicely, you want the same space between strings. So what happens is, as these strings get smaller and smaller, the center to center spacing, here to here, here to here, and here to here, gradually gets smaller and smaller. By the way, if you don't recognize this technology, this is called a chalkboard. If you make a mistake on it, you can erase it and redo stuff, and it's cheap. But anyway, welcome to room 105. I use the chalkboard a lot here in room 105. So I don't want even spacing on the nut I'm cutting. I want progressively smaller spacing or larger spacing, and that's going to leave the same distance between the strings. This is a subtle difference. It's not a big difference. We're talking about if I go even spacing versus incremented spacing, you're talking about 1/2 millimeter or so, which doesn't sound like a lot. But the thing is, if you cut these things wrong, you run out of space and you have maybe a bad nut, or you ruin something, or you didn't realize. So the better setup you are off the start, the better off things are. And if you want to just make even center to center, it'll work. Nobody but you's going to know if you're doing this. But here's how I work through. What do I want to do to get things set up for the way I want them? Let me try to get this right about where I want it. So I set up a couple things here so I can get into this quickly. I don't want to be super boring with a math lesson. There are a couple ways to do this, by the way, and I have a couple different ideas. I did 2 different things, and they both put me within 1/10 of a millimeter or less on all my sides. Either way works. I'm going to get into basically the more involved way, more customized, but there's other ways to do it too. If you're interested in like a formula or a spreadsheet, I could probably get this into a spreadsheet. I don't know. But here's the problem. Okay, I have a brand new nut. I checked it out. I measured it really carefully. The brand new nut, 42.1 millimeters. You gotta be careful of your measurements. You gotta think about how precise is reasonable to be. So that's the whole nut. Pretty standard on spacing. You want each string to be about 1/8 of an inch. I do that to the center. You could also go 1/8 of an inch to the edge of the string. I think 1/8 of an inch I think it's gonna be good the way it is. The way I did my last 2 guitars, and I like the way they came out a lot. Now, I'm gonna be working in millimeters because I found out my vernier calipers are much easier to work on in millimeters than like 128ths of an inch and all that. And if I'm gonna go to a calculator, millimeters work really well. So, 42.1 millimeters was my closest measurement I had there. 1/8 of an inch is 3.175 millimeters. So I'm calling that my edge spacing. I'm going to lose 3.175 on each side. I'm also going to calculate the loss of the width of the strings. Now I'm using a typical a set of 10s. This guitar is probably going to get 10 5s. I like to use 11s. Once in a while I go light top, heavy bottom. It's all slightly different. But all those strings, you're talking about differences of a couple thousandths of an inch. You're going to be close enough. I'm going to use these calculations here, and that's what I'm going to stick with. And if you have the same dimensions as me, you could use this. It'll work really nicely for a normal guitar setup. So here's what I do. I list out the sizes of a typical set of 10s. But the first string gets cut in half. And that would be 10, by the way, that's not 10, that's 10 thousandths. And 36 thousandths and so on. But anyway, the 10 gets cut in half because that string is going to be cut in half by that spacing. The same thing with the last string, the 46 I cut in half. We're going to lose half of that. So my question then is, from here to here, how much am I losing to the thickness of the strings? It's not a lot, but this is that little correction that's going to really make things set in nicely. And your bass strings will have the same space between as the treble strings, and it's really nice. So I add all the sizes. The 10 is cut in half. The 46 is cut in half. My answer is 120. That's actually 120 thousandths. So I put the decimal in there. 120 thousandths of an inch times 25.4. So 3.048 millimeters. That's my string width. So what I'm going to do next then is I take my whole neck, 42.1, I subtract my edge spaces each side, I subtract the string width, I grab a calculator quick. I think I already had this worked out somewhere. Yeah, I did subtract it already. So after I subtract all that, I'm left with 32.702 millimeters. So that's my 42.1 minus 3.175 and minus the 3.048. So that number represents how much extra space I have in between. That's going to be this, which is not drawn to scale. So all that is highlighted in yellow. So what I do now is I take that, that's 6 strings, but there's 5 jumps. You divide that by 5. When I divide it by 5, then I got 6.5404. Now, by the way, I know it's silly. Why am I holding on to 10 thousandths of a millimeter? I can't see that. I can't measure it. I'm going to do all my calculations as accurate as I possibly can. So when I take my final answers and round those probably to tenths of a millimeter, they're going to be good. And if a whole bunch of them round up, then as they add together, the end is going to round correctly. It's going to be good and precise. There's also one other thing I do to really make this rock solid is I'll lay it all out from bass to treble side, as carefully as I can with a very sharp pencil, and then I'll do all the calculations backwards, and I'll do it treble to bass. So each string will have 2 pencil marks, and if those pencil marks are on top of each other, I know they're perfect. And if those pencil marks are off slightly, I know that one rounded up and one rounded down, and I'll split the difference. But honestly, tenths of a millimeter, if I do this well, I'm not going to see 2 different marks anywhere. What I might see is if the nut is not perfectly 42.1, I might see a tiny bit of error because of that. But if I do it from both sides, if I do it completely and go from one side, do it completely, go from the other side, and I match those pencil marks, even if there is error, I'll split the difference, and that's going to work really, really nicely. So the next thing is, what do I do with this number? Basically, that number then needs to get half of this string and half of this string added on, and that's going to be this next center to center. And then that number gets half of this and half of this added on, and that's going to be this center to center. And then that number gets half of this and half of that, and so on, until you get to half of this and half of this, and that fills in each one of these things, which is where I'll put my pencil marks on. And the last calculation, I'll add on the 3.175 and make sure it totals to exactly the width I'm looking at. Again, I could be off by 1/100 of a millimeter. I'm not going to stress. When I actually did this, it hit on perfectly. It did a really nice job. But again, I'll do it from both sides to make sure it really works. Now that's where things get tedious though. It gets tedious because here's the thing. This is millimeters and those are thousandths of an inch. So it's annoying to crank this through a calculator still. It's thousandths of an inch compared to millimeters. It's a headache. But let me get set up here and I'll show you then what I do to make this as simple as possible. I'm going to do some erasing now and make some space on the board. This is my important number, and those are the strings I'm working with. So I don't really need the other stuff around here anymore. I'm going to erase, and I'm going to set up and show you what I do with a calculator in hand and make sure all goes the right way. And again, this is pretty universal to whatever you want. What's the difference? Maybe you want a slightly different string spacing on the edges. You know, maybe instead of 3.175, you want 3.2 or 3.3 millimeters. Don't go less than 1/8 of an inch. Don't go less than this number. Maybe you want to calculate with a light top, heavy bottom set. Okay, that's going to change some things maybe, and some of the spacing changes. You know, you want to play with a wound G string or something else, like whatever you substitute some other numbers, work through, it's going to be similar. If you happen to have that size neck and you want standard strings, this is going to work for you. And if you calculate for these and you decide to put 9s on, again, you're talking about thousandths of an inch. It's not going to hurt. The spacing is still generally good from thicker strings to skinnier strings. It's generally good. So don't stress about little differences. Once we calculate this the best way possible for a normal set, that's going to work. But double and triple check your work. You know, one thing we'll watch out for is how do you audit your work and make sure that it works before you start filing slots. To me, it's do it from both sides and then have a look at it and make sure it looks like it makes sense. And then you start filing carefully, right? Because once you start going, don't forget there's also a radius there. So then you got the depth of those slots to worry about and the contour. What kind of shape do they have? We'll talk about that a little bit too as this thing winds down. So I'll use the chalkboard for some of that. Let me erase though, grab a calculator, and I'll show you what I do with this number and those numbers and put it all together. Okay, so second part of using all the calculations there. I don't care anymore about the total string width. I use that to make the calculations I needed. What I do need now, and again, I'm careful with this. I'm going to make calculations far more precise than I can actually use, but then I know they're rounding correctly and they'll be practical. Right? So it takes 10 minutes of work, but I cut all my strings in half. Right, the 5 was already cut in half. The 46 was already cut in half, so those don't change. But I labeled them now as being in thousandths. Some of those actually go to the 10,000ths when I cut those in half. So again, this is a little bit of this theoretical. Like I can't measure that fine, but I want the theoretical correct number so I can do this now. Here's what I actually use then, measured in tenths of a millimeter. We start off the far side, and here's what I want. I don't want to measure string to string, string to string. What I want is measurements that I can line my ruler up on this edge very carefully and measure each one from this edge. So what's the total distance I need? And then again, I'm not going to do all this, but what I do second then is I do all the same stuff but calculated backwards from small to thick, and I come back this way. And I lay both of those measurements out on the nut with a very sharp pencil. It's worked really well for me. It gives like professional results. So here's what we got to do. This is going to be 3.175. Again, I'm putting tenths of a millimeter then in real life. This is the measurement I'll actually use when I'm laying out. So the first E string, 3.2 millimeters is my target. The A string needs to be the more accurate version, 3.175, plus the space between the strings, plus half of the thickness of the E, half of the thickness of the A, converted to millimeters. So I add those together, convert to millimeters. What this looks like is this. 3.175 plus. Okay, so I run all that through. Depending on your calculator, you want to watch out what happens here with order of operations and all. If you want, you could convert all those to millimeters first. I didn't bother. That just sounded like more work, you know. Again, once I get the numbers, I got the numbers. So I run that all through. It's a big, ugly mess. I hit equals, and the calculator says 10.7568. Again, I'm going to round that. I leave it on the calculator accurately, but I round that and say like 10.8 millimeters. That's how far from the edge the A string goes. Okay, D, I do the same thing, but now I put the 0.018 plus 0.013, which is 3 and 8 is 11, carry the 1. I run that through the calculator. That gives me the D spacing. So, and I don't clear this off. I keep that most accurate, not rounded number in. If I start rounding and then using rounded numbers, then there's error and error in the calculations. I'm a human, I'll have error anyway, but I'm going to do the calculations as tight as I can. So from the 10.7, the full decimal there, I'm going to add. Okay. Next number. Again, way more accurate than what I can do. 18.08. I'm going to put 18.1 on the board. Again, those are measurements off the edge that I can look for on a ruler now. Consistent, careful, doing all that. The next one. Next basic, half the G string in there. So I'm going to round off to tenths of a millimeter, 25.2. $32.1. $38.925. All right, then my check is, I'm going to leave that accurate. When I add the other 3.175, do I land at 42.1? Yeah. $42.1. So again, that's a double check to audit yourself and make sure that the whole thing totals to the right. We don't need to use the 42.1, but that's checking and making sure that the whole thing works. What does it take, 5 minutes? I don't know. It's worth it, I think, to make sure you know what you're aiming for. This is not a store-bought nut. It's not some cheap plastic nut on a guitar. This is a nice bone nut that I'm doing myself. I'm going to get that all settled and taken care of. I lay this stuff out. I put pencil marks, and then I very carefully, I put on magnifying glasses. I very carefully start filing away, and I start the notches in the right place. And I'm careful about it. If your neck is a little different, that might change this number. It changes that number. If you want to try a different set of strings, you can play around that stuff. But there's what you got to do. String by string by string by string. Like I said, then I'll go from narrow back. I already did this last night, so I'm just going to make sure that my numbers, this is what I did. This is my ugly work from last night. It looks horrible. Yeah. So this is what I'm expecting to see. So it all goes the right way, except I had 10 points. Oh, well, that would round up. Yeah, I didn't round on this. I left it rounded down. Yeah, it's all the same. Now again, I have one other method I use here, using arithmetic series of numbers. That's some nerdy, geeky math stuff. You can use arithmetic series as well. I did it that way also last night, and it only changed a couple of these increments by like a tenth of a millimeter. Like, I'm not going to stress about having 3 different ways to do this if the only difference is a tenth of a millimeter, almost not even a visually perceptible thing. So I'm not saying this is the only way. I worked out another way. I think the other way is cool, but it also was more theoretical work than just cranking through a formula. So anyway, that's that. You have questions, let me know. I'll try to respond if I can. I don't have a spreadsheet for this, but I could probably make one. I don't know. Hopefully this is self-explanatory. I mean, not self-explanatory, but you go through the steps with your numbers, and it works. Let me also just mention something. While I have the chalkboard here, what else am I going to do with how I profile the cutting the nut? Because I'm going to be getting to that next. All right, so last thing here while I have the chalkboard, this is a very crude diagram of where the tuners are on the head, the fretboard starts, you got the nut up here, fretboard, that'd be the first fret out that way. So something about the nut you want to watch out for is that, first of all, you do want to, from one end to the other, you want to round them off so it feels nice in your hand. You don't want sharp corners there. You also want to round it back towards the tuners. So this thing will take a little bit of this kind of a shape as I'm working on it. And again, that's not to scale, but I'm going to round it off to the back there a little bit. And within that, you also want the slot to round off and down. You want that slot to go off and down a little bit so it's not pinching the strings. What you want is where that string comes in. So there's the top of the nut. The string is actually going to come in, you know, just below the top. There's a notch cut down in. And what you want is for that to also fall away, so that the break point is right there at the front of the fret, and that everything below is getting pulled back and down towards the tuners. So when you play an open string, it's essentially stopping it right there. If your fret is flat across the top, it can vibrate from the front of the nut or vibrate from the back of the nut, and what'll happen is it's gonna not sound good. It's not gonna sound proper. It's not tuned nicely or anything else. So you want that slot to kind of dive off. You want to make the nut a comfortable contour so it looks nice and feels nice, but you want the slot itself to be contoured so that the front top is where it's making contact. Now listen, you don't want it to be a hard angle, like the front of that nut. You don't want to come like this to a hard angle, because that'll wear out. You want it rounded so the string comes and then falls away gradually to the back. If there's no support there, it's not going to be strong. You don't want to file straight down this way, rounded. So the nut profile is rounded and the string slot itself is rounded. Now you want to be fancy, especially if you use a tremolo a lot, not only rounded so it dives off, I should go this direction, so it dives off as it goes down and over, but also you want that string slot to widen slightly. You want it narrow to capture the string at that front leading edge, but the slot itself down and wider. So here's the best way I can describe the contour of the string slot itself. Imagine the bell of a trumpet. You can imagine a trumpet, right? So it's tubular, and as it goes, it's getting bigger. And it's kind of radiused this way, and the whole thing is circular, so it's that kind of a shape. It flares. The bell flares. You want the string slot itself to flare. You're talking about a couple hundredths of an inch, but you want it to trap the string in a narrow part of the flare at the front, and as it goes off the back, you want that flare to just open slightly. It opens downwards and opens up slightly. And so I'm talking like when you're filing that slot, all I do is I just give a little bit of extra attention to the back edge of the slot, a little extra, a little deep. That's probably about all it needs. You don't want a hard angle. You don't want to exaggerate that too much. But if you open that up a little bit, it's going to really make that thing tune up nicely and play nicely and all that kind of stuff. So I think that's about it for the math of guitar nuts. It's time for me to go home sometime soon and actually make this happen and get that thing in there. So that's it for today. Hope I could teach you something. When's math going to help you in the real world? Well, hey. Take care.